So that should be something of interest, right? Similarly to the idea of orthogonal component of acceleration with respect to velocity. So now we are at a similar stage in this consideration. Now what was our next step? After we realized, well, orthogonal component of acceleration with respect to velocity is something to look at. Why is it that we decided it's not good? Why is it that we looked at these scenarios of two particles moving differently? Well, because we realized that quantity depends on the speed. So it carries not only information about geometry that we want to extract, but also information about how quickly the particle is moving. So that's exactly why we looked at two different particles moving with two different speeds, and then wanted to compute that for both and compare results. So that's what we should do for both particles now. And the formula is very simple, right? Basically we have to find this volume on three vectors. So one volume is easy. It's the volume on f prime volume on f prime of t, f double prime of t, and f triple prime of t. And on the other hand, we have to compare that volume to the volume on g prime, g double prime, g triple prime. And the way we can do it is by substituting all these formulas into that volume. Well, that's exactly what we did for the curvature. So what if I substitute all those formulas? So f prime is g prime. Well, when I write g prime, it means with respect to s. And when I write s prime, it means with respect to t. So I will not write those arguments anymore. Then f double prime is g double prime times s prime squared plus g prime times s double prime. And the last term, f triple prime, is the longest, so it is g triple prime of s times s prime cubed plus g double prime times 3s prime s double prime plus g prime times s3 primes. Okay, that's the volume I have to look at. Now let's pause at this moment and think about our prediction. Can we predict anything? Do we have any expectation of what it should be? Because probably this formula is not going to be the final. Probably that formula will depend on how quickly we move. Right? How can we fix it? Can we make a guess? Because remember, last time we made the guess, we looked at the circular motion. And for the circular motion, we know the formula of relation between acceleration, normal acceleration, and velocity, right? There is this quadratic relation. 1 over r is acceleration over velocity squared. Do you have any formula related to this? Have you ever studied typical three-dimensional motion? That should probably be along the spiral. But even that is not obvious. So that means we have no prediction at this point. So we have to follow the computations and do it carefully. Because whatever mistake we make, we will not be able to check it.